In this video, we're going to see the last part of Lab 13. In the last part of Lab 13, students will be exploring the cleaning capacity of soaps when we are dealing with soft water, hard water, or very hard water. The different samples of water, they are in the drop-down menu on the left side of the simulator. And here, distilled water is considered soft water. Well water is going to be hard water. And distilled water plus calcium chloride is considered very hard water. The steps for each are going to be very similar. So follow along with all the steps that I'm going to perform now. So let's first start with the steps for the distilled water. First, we're going to take the soap and we're going to place it in the beaker. Then using a glass rod, we are going to solubilize some of that solid soap. To completely dissolve the soap, we are going to heat up the solution. And as you can see, that solid soap completely gets dissolved in the process. We're going to turn off the Bunsen burner. And as you can see, in the beaker, we have a soap solution with distilled water that is almost clear. Next, we are going to take this test tube and we're going to pour some of that soap solution that has distilled water. We are going to zoom in into the test tube. As you can see, we're going to move this to the best of our abilities. The length of this solution in centimeters is about 10 centimeters. So make sure to use whole numbers when you're entering this data into your lab quiz. Now we're going to click on the test tube, and when we zoom in on it, we can see how some foam has been formed. Utilizing our ruler, we can measure what is the length of the soap solution and what is the length of the foam. So if we look closely at this portion of the experiment, we can see that at up to 6 centimeters, so at 6 centimeters is going to be the length of the soap solution. And because from 6 centimeters up to 13 centimeters, that's where we see the foam is going to have a length of 7 centimeters. The last step here is going to be what is the cleaning capacity of this soap that is considered to be soft water. We're going to have a piece of cloth that has been stained. We're going to pick it up, put it in the beaker, and after our digital clock has completed 10 minutes, when we look at a closer view, we can see that the ink spot in the cloth completely disappeared, indicating that the soap solution with that soap water has the most cleaning capability. Let's move on to the next sample, which is the well water. We're going to start with the same first few steps. We're going to take some soap, putting it in well water. The glass rod is going to help us solubilize some of this soap. To completely solubilize that soap, we are going to warm up the solution. And we're going to, as you can see with the glass rod, completely dissolve the soap. So now we have a soap solution that is made in well water. Now notice that this, because it is considered hard water, there is some turbidity in the solution. So it's kind of turbid. Next, we're going to click on the test tube, pour some of that soap in hard water solution. We are going to zoom in. As you can see, the ruler marks that this soap solution starts at 10 centimeters. Next, we're going to click on the test tube. And when we zoom in on the test tube, we see that there's less foam. Utilizing the ruler, we can see that the red marks the original value of the solution. So once we are looking at how much soap, how much foam has been formed, we can see that the length of the soap solution is at 8 centimeters. And because the foam is in between 12 and 8, that means that the foam form is only 4 centimeters in length. As you can see, a soap solution with well water produces a smaller length of lather, meaning the foam that is formed. Lastly, we're going to put the piece of cloth that has been soiled or stained, and we're going to look at the cleaning capacity of a soap when it's placed in hard water. As you can see, the stain, it's still present there. When we click on the eye icon, it says that the ink spot on the cloth has partially disappeared, so it's not gone all the way. When we are comparing this to the distilled water sample, so that means that well water compared to our distilled water has less cleansing capacity or capability. Let's move on to the last sample, which is distilled water with calcium chloride, which is our sample with very hard water. We're starting with the same few steps. We put the soap in the beaker. The glass rod solubilizes some of the soap. To completely dissolve the soap, we need to turn on the Bunsen burner and heat up our solution. And this makes sure that now we have a soapy solution in that distilled water calcium chloride solution. As you can see from the beaker, it's hard to see, but there is some soap scum that it is formed. We move to the next step. We take our test tube. Some of that solution is poured. When we look at it, as you can see, we start at 10 centimeters. Then the test tube is shaken. When we zoom in, we can see that in conditions of very hard water, we have even less foam. So when we look at the measurements, we started close to 10. Then we can see specifically when we're here that the length of the solution is around 9 centimeters. It's around 9. And then since our foam is between 9 and 11, then that means that there's only around 2 centimeters of foam produced. So that means that the soap solution with distilled water that has calcium chloride, in other words, very hard water, produces the minimum length of lather compared to the other 2 samples that we have. In the last step, now we're going to observe what is the cleaning capability of this very hard water. We put in the inked cloth, and when we zoom in, you can see that the stain is still there. No change in the color of the ink spot has happened, so that means that very hard water has the lowest capability out of the 3 samples.